Hi, everybody. This is an introduction to enzymes. We're going to look at enzymes in general and how they are regulated. Um, so let's get going here. So enzymes, you can see the reaction going from the middle top down to the middle right side. Um, we're going to go through that reaction. We're going to talk about some of the little intricacies that go on through it. So first off, what is an enzyme? You should know it's a protein. Um, And sometimes we have things called ribozymes, so they're sometimes made of RNA. They are reusable. So by the beginning to the beginning shape is the same as the end shape. They catalyze reactions from substrates or reactants into products and speed up those reactions. Some enzymes will require a little ATP to function, but often the reactions that enzyme catalyze wouldn't happen fast enough, fast enough without the enzyme. So there's two different models in which we use to describe and understand how enzymes work. The first one is called the lock and key model. And the lock and key model means that the enzyme almost locks is the lock and the enzyme is the key and it is unlocking the substrate into the product. So the idea is that they actually fit in perfectly. Now, if you look at an induced fit, I kind of think of this more like a clay model, if you will. You'd have a clay enzyme that fits, that the substrate fits into, and the clay slightly changes. Um, and it might actually slightly change to make it a better fit, or it might slightly change to break the products or break them into products. Okay, so what are some things or ways that we can regulate enzyme reactions? So the first one is that enzymes, again, made up of proteins. So proteins at different types of conditions can be kind of like their shape can be changed or messed up. And we call that denaturing the protein when it loses its natural shape. So temperature is a big one. Temperature really can dramatically change the shape of the protein. pH can also change it because different positive and negatives that are caused by the H pluses can cause it to change shape. It can be attractive to different areas. And then salt concentration can also change it again. Positive and negative charges can pull positive, negative parts, amino acids, away from where they would have already been. We could have what's called a non-competitive inhibitor. A non-competitive sounds like it's not competing. What they're not competing for is the active site. The active site is the location in which the substrate and the enzyme bond together. So they fit in an other site. Allosteric means other site. Okay. And so let me go back to that. I'm sorry. So when they do bond there, the non-competitive inhibitor binds there, it actually changes the shape of the active site because it changes the shape of the whole enzyme. A competitive inhibitor, they're going to compete for that active site. So is the competitive inhibitor, you notice is kind of a similar shape there as a substrate. You could fit right into that active site and thereby preventing the substrate from binding to the active site. A lot of these can be reversible because they can leave. They can leave that site. And then what other molecules could cause an effect like here? So one of the things that could help are things called coenzymes or even cofactors. So the reason your mom and dad made you take vitamins when you were younger and continue hopefully to this day is because vitamins act as coenzymes. They assist in helping some of these enzyme reactions to take place.